Okay, hi, it's nearly 5:30 and I'm about ready to start going through this higher paper. It's a little bit nerve-wracking, I'll be honest, not because of the technology, but more because of the maths. I genuinely haven't seen this paper before. I've tried to put myself into a position like you would be in an exam. It's all going to be brand new. So I've got my kit. I've got pen, pencil, protractor, ruler, or the normal examination kit. The only thing I guess that's different is that I'm going to be talking through the paper as we go, and we'll see how we go from there. So let's make a start, I think. I'm not going to bother putting my name and stuff on it, we'll just kind of crack straight on. So, first question. By the way, hopefully you've picked up your paper today after the English exam today, and hopefully that's gone really well for you. So say if not, then follow along as we go, and fingers crossed you'll be able to see as we progress. Okay, so let's get some maths done then. I'm going to try and talk my way through, looking for the key things all the way. First thing we've got then is an indices question. We've got x to the power of 6 divided by x to the power of something equals x to the power of 8. Well, I know that when we're dividing, we're taking away. So 6 minus a is 8. 6 minus something gives you 8. A has got to be a negative value, and that's got to be minus 2. So minus 2 on my answer line. Next one, we're looking at simplifying. I like to deal with the top line first and then deal with the bottom line afterwards. So we've got 10, we'll do the number bit first. We've got 10, b cubed times b to the 6 is b to the 9 divided by 3b to the 4. I can cancel some of these out, but I can't really do anything with my fractions here, so I'm just going to leave this as 10 over 3. My b's power is at the top, so b 9 take 4 is 5. So 10 over 3, b to the 5. Again, just write it on my answer line. 10 over 3, b to the 5. Finally, I've got a simplifying question. I feel like these are quite nice, a good introduction. I feel quite comfortable with these so far. Simplifying, so we've got a power on the outside of my bracket. The thing that I have to remember is not just to deal with the powers here, but to remember to do 2 to the power of 4 as well. So we've got 2 to the power of 4, and I'm timesing my numbers, my powers. So 2 times 4 is 8. What I need to do is do 2 to the power of 4. Now this is an easy sum. I can do it without a calculator, but to be honest, I'm in an examination where I've got the power of a calculator, so I'm going to use it. So 2 to the power of 4 is 16, and I'm just doing this so that I'm minimizing any chances of any errors. So I've got 16 m to the 8, 16 m to the 8. Okay, so first page done. So far so good. Let's turn over. Next one, we've got a standard form question. Writing this number in standard form. I'm pretty sure there's a way we can do this on our calculator. Let's type it in and see. So 987 0 0 0 0. If we then press equals, and we're looking for our engineering button. There we go. So I'll press my end button up here. Gives me in standard form straight away. So there's nothing else that I need to worry about, and we just go 9.87 times 10 to the power of 6. Okay, that's a really helpful button. Definitely have a, if you've not used it before, standard form, that's the way forward. Okay, next one, more standard form. Again, I've got my calculator, so I'm going to do this sum on my calculator. I'm literally just going to type it in as it looks. So notice I put a bracket first, because the first thing is a bracket. 9.2 times 10 to the power of 6, close bracket, divided by 3.4 times 10 to the power of 8, and I get a fraction, 23 over 850. Press my FD button, gives me a horrible looking number. But reading the question very carefully, give your answer in standard form to 3 significant figures. So the first thing I'm going to do is write this to 3 significant figures. So not 3 decimal places, but 3 sig fig. So that's going to be 0.0271. So 0.0271, and then that number I'm going to turn into standard form. Again, I can do it on my calculator, pressing my engineering button. And oh no, my engineering button's given me an interesting answer here. And I know it's got to be 2.71. So I'm actually going to ignore my calculator. It's very interesting. I didn't expect it to do this. Standard form has to be between 1 and 9.99, etc. And this is going to be an answer of 27.1. I know it's got to be 2.71. So let's go 2.71 times 10 to the power of, and we'll do it a little bit old school. Let's count the decimal places. We've got 2, so minus 2. Okay, moving on. Next question. Charlie is investing some money, £5,600 for 4 years in a savings account, and she gets 2% per annum compound interest. So this 2% we can write as 1.02. That's my 100%. Here's my 2%. We're doing it for 4 years. Simply just type this in and away we go. So 5600 times 1.02, the power of 4 equals. And again, we're dealing in money, so I'm going to write down the whole number first. 6061.620096, and the money answer, and put at the bottom 6061.62. Okay. Just checking that everything's okay. The screen I'm looking at says that we're still live, but it looks like it's buffering, so I'm just checking that everything's fine. If it is, if somebody can send me a message, that would be fantastic. Otherwise, I'm just going to continue. Next question we're looking at then is a ratio question. We've got some football team selling home shirts and away shirts. The ratio of home shirts to away shirts sold is 5 to 1. So this 5 to 1, we need to be very, very careful that this means 6 parts. The shirts can be adult shirts or children's shirts, and the ratio of adults to children is 3 to 2. So again, this is 5 parts. What proportion of the shirts sold are children's home shirts? Okay, so children's, we've got adults and children, so we've got 5 of the 6, so 5 6, and of those we want the children's part, which is 2 out of 5. Here we go. So we've got 5 6 times 2/5. Again, I can do it without a calculator, but I'll probably just check it again, just because it's a slightly stressful situation for me, and also I don't want to go wrong. This is probably the last chance you're going to get to show off all your math skills. There's no point in making any silly errors. And we've got 10 over 30, which cancels down to a third. Write it on my answer line. Okay. Right, let's keep going. I can see comments still coming through, so I'm assuming that everything's fine. Okay, next one then. We've got some average house prices. Average house price in London in 2017 was something. In 2018 it was something else. Looks like it's gone down. We're doing a percentage change question. Okay, easy way to do percentage change. We do the change divided by original and times by 100. So my key things that I need to do here is work out the difference between the two. I'll do that on my calculator again. So 474902 take 469538, gives me 5364. So the change is 5364. Okay. Next thing then, we need to divide that by the original. 5364 divided by, now the original one was where it started at, so in 2017, 474902, times it by 100, and we're going to get our answer. So divide by 474902 times by 100, and we've got this. And again, I'm just checking that there is nothing in the question that says to what the number of decimal places. We've got 1.13. I'm going to round it to, so 1.13%. Okay, let's keep going. I'm very impressed with the comments that are coming through. I'm not entirely sure that I'd like to be president, but thank you very much anyway, everybody. Should we just keep moving on to the next one? Again, I'm still looking through the comments just to check that you can see what I can see. I'm now doing question 6. If somebody can just put a comment on, say, question 6, that would be helpful, because all I can see is a little white circle that's just spinning round and round and round. Thank you. Okay, so next one. Let's have a think what's going on here then. We've got in London potatoes cost, okay, so we've got a pounds to pounds and we've got a euros to kilograms, and we've been given this exchange rate for both kilograms to pounds and pounds sterling to euros. So I think the thing to do here is to sort out what we're going to do with working out the best value. We need to get it so it's all in the same kind of language, if you like, and I need to turn it into either euros per kilogram or British pounds per pound. I feel like the easiest way to do it is to turn it into British pounds per pound, so sterling per pound, and I'll compare it from there. So we've got Dublin 1.48, and we are converting this kilograms into pounds, so I want to divide by 2.2 here. Again, use a calculator. 1.48 divided by 2.2 gives me, and not a very nice number, but I'm just going to write all that down, and that is 0.6727, and that recurs. I'll just put a couple of dots at the top there. Let's do a similar thing now. We need to compare this. This is, just write down what this is, 0.6727. This is euros per pound in weight. Okay, right, I think the next thing to do is to convert my euros into British pounds, because then I can compare my London potato prices. So 0.6727 recurring, and I'm going to convert it using this conversion, the 1.15. So dividing by 1.15 gives me 1.15 0.58 and a bit. I'm going to go 5, and this is now pounds per pound. So let's have a look. This was in Dublin. This was all Dublin. So Dublin said it's going to be like 58.5 pence per pound, compared to in London where it's 45 pence per pound. It quite clearly asked me a question. It says I've got to show my working. Okay, so this is the Dublin stuff here. London is cheaper as it is 45 pence per pound, compared to Dublin at 58 pence per pound. Okay, it's going okay so far, I feel. We're getting into it a little bit. Okay, just having a quick look through the messages. again, just a whole lot of love for me, which is lovely, and thank you very much. I'm not entirely sure what my my views are on Brexit, and actually they're not particularly relevant to this paper, although maybe question 6 is interesting with the euros and pounds. We could probably go off on a little bit of a tangent there, but we won't. Okay, let's have a look at this ratio question then. So Andy and Bruce share some sweets in a ratio of 9-4. Andy gets A, Bruce gets B. Colin and David share the same amount of sweets. Okay, same amount of sweets as Andy and Bruce. They share their sweets in the ratio of 5-2. Interesting. Okay, so we've got numbers here that don't really, nothing kind of jumps out at me. I feel that the best way to do this is to scale them up to the same kind of proportions, and probably the best way to do that is to work out the number of parts. So again, we've got 13 parts here. This is 7 parts, and we've got 9-4, and we've got 5-2. Now this 9-4 that was the 13 parts, I'm gonna kind of do, it feels like I'm doing some kind of fraction work with this. I'm trying to work out, if I had 7 lots of that and 13 lots of this, I'm going to be able to balance this out. So I'm going to do all this multiplied by 7, and I'm going to do this thing multiplied by 13. 63 to, I should know what 4 times 7 is, but again, I'm in an exam, a pressured situation. Just going to use my calculator, and we're going to compare that to C and D. So 5 lots of 13 is 65, and 2 lots of 13 is 26. Now, before I write this down as my actual answer, I just want to double check that if I add these numbers up and these numbers, Andy and Bruce and Colin and David are actually getting the right amount. Okay, so 63 and 28, if I add those things together, it gives me 91. And if I add these two, I get 91. So happy days. Here are my numbers. 63 to 28 to 65 to 26. Okay, hopefully you can see that. These ratio questions on higher, somebody asked before and said they really don't like them. They can genuinely be a little bit tricky. I think have a strategy, think your way through it. I tend to scale things up or draw a bar model. This one I didn't feel lent itself to a bar model type question, so I literally just scaled it up. Okay, let's keep going. We're on question 8. I've been doing this for maybe 15 minutes or so. Possibly need to speed up a little bit if we're going to finish in an hour, but we'll see how we go. So list the members of A and B. So the things that are in both A and in B are here. 1, 3 and 8. 1, 3 and 8. They're both in A and they're in B. A number is chosen at random from the universal set. Find the probability that it's in B or C. Okay, so I literally just need to count the numbers that are in B or C. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 of those and 2 here. So that's 10 out of 12, giving me 5, 6. Okay. Quick recap of these symbols. I like to think of it like this, and, so if it's in A and B, and this symbol, I always think of it as or. Quick tip. Okay, next one. Adam. Oh, Adam's cool. He's measuring the heights of his tomato plants. Why wouldn't you, Adam? Absolutely. So, let's keep going. Estimate the mean height. So this is a bog standard mean from frequency table. These haven't come up on paper 1. If it doesn't come up on paper 2, it's definitely going to come up on paper 3. Let's go. Midpoint times frequency, add them up, and easy peasy. So let's get your midpoint. 145, 155. I'm checking each one. I don't just want to make sure. I don't want to just assume that they're all going to be the same. Although it looks like they are going to be. Ah, no. The last one, Last one's got a bigger class width, so this one is 190. It's very easy just to get into a habit here without actually checking each time. So please don't do that in a real exam. Next one, midpoint times frequency. So I'm going to use my calculator at this point. 145 times 7. 1550. 15 times 165. 19 times 175. And 9 times 190. And then I must remember to add up these. So I'm adding them up and I'm dividing by the total. So the other thing that I need to do is that there are not 1, 2, 3, 4, they're not 5 I'm dividing by. This is a common mistake. I need to add up my total frequencies as well. So I might do that bit first. 7 plus 10 plus 15 plus 19 plus 9 is 60. So Adam's got 60 tomato plants. He really is cool. I'm very jealous of Adam and his tomatoes. Let's add up all this stuff then. Interestingly, he's called Adam, as that is in fact what we're doing now. We are adding them. Wow. Okay, and we've got 10,075, and finally we're doing the ones that I've added up divided by how many there are. And when I get an answer, 167.92 we're going to go for. There's a couple of things I just want to point out at this point. These are in centimetres, and you'll notice at the bottom of your page you've got centimetres already. I'm just going to write it in. Because it says estimate, you might be tempted to then round this or do some estimation here. You don't need to. You absolutely don't, because we've already done the estimation by finding the midpoint. The final thing that you might be tempted to do is to round it even further, or just round it to 168. The examiner will allow you plenty of leeway on the rounding, because the question doesn't say to give it to any particular decimal places. I think 2 would be reasonable here. Okay. Again, I'm just having a quick look through. Walton for Prime Minister seems to suggest that I've got the wrong answer. You might need to be a little bit more specific there, Walton for Prime Minister. Which question do you think I've got wrong? I'm happy to go back and have a little look. Okay, next question then. We're looking at a density question. So these ones, I feel like I've done similar questions to this with groups in the past. Okay, so 100 mils of liquid A and 200 mils of liquid B are mixed together to make liquid C. We've got density, we've got mass. It's a density mass volume question. Before anything else, let's just write down my DMV triangle, and then from there it'll be much easier to do. Okay, so liquid A. Let's work out what we can. Liquid A, we've got a density and we've got a 100 millilitres. So 100 millilitres, are we thinking that that's the volume, or are we thinking it's the mass? It's got to be the volume, because here we've got G, grams for mass, and we don't have anything about grams. So I'm going to do density multiplied by volume. Liquid A, 100 multiplied by 0.8 is going to give me, again, very simple calculation, but I'm just going to check, 'cause it's so easy to make an error. 80 grams. So I've got 80 grams of liquid A. Let's do a similar thing for liquid B. I've got 200 millilitres, and that's got a different density. So 200 times 1.1. Again, don't take any chances, just do it on your calculator. 220 grams. And these two things have been put together. So I've got a total mass now of 300 grams. So liquid C is 300 grams. We're trying to work out the density. I've got 300 grams, and I also know the volume. The volume is when I've combined the two liquids, 100 ml and 200 ml, which is 300 ml. And I want to work out density. So looking back here, I'm doing mass divided by volume. 300 divided by 300, which I'm not going to use my calculator for because it's just 1. Okay, easy. I say easy. Easy if you remember your triangle. This is the key bit into the question, and then just start doing the maths. It'll all come together. Okay, question 11. We're changing centimetres cubed into metres cubed. There's a good chance that you won't just be asked to do it like this in an exam, that this will be part of something else, but it's absolutely a key skill that you need to be good at. So, here we go. Let's do centimetres to metres first. So if it was just a linear scale, then there are 100 centimetres in a metre. Now we're doing it cubed, so we're going to have to do 3 lots of this, so we're going to get 100 cubed. So if we're changing this and we're using this, then I'm going to do 4500, and I'm going to divide that by 100 cubed, and that will give me my metres cubed. And again, just using my calculator. And we've got 0.045. 0.045. Okay, I can see some people have mentioned about some answers online. You are absolutely correct. This is not a paper that I've made. This has come from a website called mathsgenie.co.uk. Rather than me make it, I've deliberately taken a best guess paper that somebody else has done so that I can go through it as if it was live for me. I think some of the skills involved in doing an exam paper are not just the answers, and of course you can see how I'm doing it so that you get the answers, but there's another skill, and that's me picking out and trying to verbalise what I'm doing if I was in that exam situation. I think there's a lot of benefit from doing that. Okay, next one then. So we've got a shape question. These ones that have no angles in, again, you need a way in. The way that I like to get into these sorts of questions is to start with my exterior angle. That always tends to be the way forward, but I'm going to read the question first and see what else we know. Shape A is a regular triangle. Okay, so the word regular is interesting here. We don't really hear the word regular with triangles very often. The typical thing to hear there would be equilateral. Regular just means that you've got 3 angles the same and 3 lengths the same. So straight away I can tell you that there are 60 degrees in each of these. Now this might be really helpful because we're going to use some angle facts to help work out how many sides this polygon has. Shape B, again, regular octagon. So I'm going to find an external angle first, and because external angles always add up to 360, this is an 8-sided shape. I'm going to do 360 divided by 8, and that gets me 45. And then I'm using angles on a straight line. So my angles on a straight line fact, 180 minus 45 gets me 135 here. Okay, so if this is 135, because this is a regular shape, this bit up here must also be 135. In total so far, I've got 60 plus 135 is 195. The other part of this shape is going to be whatever angle it is that will make it add up to 360. So 360 minus 195 is going to give me 165. So the interior angle of P is 165 degrees. Now this isn't a shape that I know off the top of my head that has an interior angle of 165. I'm going to use my exterior angle fact again. I'm going to take that away from 180. So 180 minus 165 gives me 15 degrees, and then I'm going to do 360 divided by 15 degrees, and that'll tell me how many sides my shape has. So 360 divided by 15, 24. So this is a 24-sided shape. Okay. Okay, next one then. Just reading through the comments, it's interesting that people want main. But as much as you might want Mr. Main, you can't spell his name, unfortunately, so I can't imagine him being overly impressed with that. Right, next one. On the grid, shade the region that satisfies these inequalities. I'm just going to treat these as straight lines to start with, and then we'll think about the shading afterwards. So I'll need to first of all get my pencil and ruler. First one we've got is y, and I'm just going to say equals because that's the line I'm going to draw. Y equals x minus 1. So starting at minus 1 and checking my scale. It's got a gradient of 1, so every one along. I'll just draw this nicely. Okay, so there's my first line, and we want all the things that are bigger than or equal to this line. Okay, well, we'll come to that a little bit in a second. Next one. Oh, interesting. This one is not in the normal form, so I think the best thing to do here is to rearrange it and put it into a regular, or yeah, I think maybe y equals mx plus c, or I might just do. I think I'm just going to bring my 2y across to the other side and say 2y plus x is less than or equal to 6. So I literally just moved it across. By doing it this way, I can use my cover over method, which says that if y is 0, x is 6. So I can put myself across at 6. You can't quite see I've done that, but there you go. Put across at 6, and when x is 0, y would have to be 3. So when x is 0, y would be 3. I've been silly. I've done that wrong. Okay. So when y is 0, x is 6. I'm saying x is 6, but I'm drawing the wrong thing on. There we go. And this one is 3 up here. And join them up. Again, taking time. Get it nice and neat. And the final one is minus 3. X minus 3. So that is going down through here. Okay, now we want to work out which side of the lines I'm shading. Now it does say a region, so I think if you're really unsure, you've only made one region, but I think it's worth checking. We want y to be bigger than this line, so that's everything up here, and straight away we can see that this is looking like it's going to be everything up there. We want x to be bigger than minus 3, and again I'm not going to do anything else. I'm just going to shade this in, and we're happy that this is my region. I'll do it in pen now. So that's my region R. Okay. Moving on. Question 14. We're up to the staples, and we've been going about half an hour. So I feel quite happy, quite confident that I'm on time. Again, I think it's always worth you just checking as well, having these reference points so that you're comfortable. There's going to be some harder ones coming up, and I'm trying to do this in a third of the time. Okay. Right, next one. Next one we're going to do some prove algebraically the recurring decimal can be written as this. Okay, so with the recurring decimals, I always do it to get in exactly the same way. We say let x equal 0.527 recurring. So I'm just going to put some more 27s on and some dots after it. What I'm going to then try and do is I want to try and get rid of these, and the best way to do it is to take them away. So I'm going to continue to multiply this up until I can get all my 2s and my 7s to balance. If I times it by 10, so 10x would be 5.2727272. They don't quite line up at this point, so times it by 10 again, and I get 52.7272727. And at this point things do start to line up. I can see that this one and this one, if I take this away from this number, I'm not going to be far wrong. So 100x take an x gets me 99x, and the next bit I'm going to do on my calculator, I'm going to do 52.7272 take away 0.5272, which gives me 52.2. Okay, it's not perfect, but it's a lot better than it was before. Let's divide through. So let's go x equals 52.2 over 99. We never have a mixture of decimals and in a fraction, so I'm going to times both sides by 10, and that will give us a sensible answer. So 522 over 990. And there's no space to put my answer, so we're good to go. Okay. Okay, let's keep moving through them. Next one, we've got an iteration question. Again, this is where your calculator comes in. These questions, let's just have a quick look. There's 3 marks for this. As soon as you see your iteration, you should be over the moon, because these genuinely are easy to work with. The best thing to do is to start when it says x0 is 3. So we're going to go, so you can see, 3 equals. All that does is stores 3 in the memory of your calculator. And then I'm going to type in exactly what we see here. So I'm just going to zoom in a little bit. So it's the cube root of 9 plus 8 lots of your value. So what I'm going to do is the cube root of 9 plus 8 lots of ants. That's all I want to do. There's a couple of things that I need to be careful of. My cube root button is here, it's in blue. Got to do that rather than 3 lots of the square root. So I've got 9 plus 8 ants. And then don't get too excited with the equals button. First time you press it, you're going to get your x1 value, as it's asking for down here. So I'm just going to write that in. 3.20753,433. And then you don't need to do anything else other than press equals again. The reason being, this ants, this number is now your answer. So the next time I press equals, we're doing the cubed root of 9 plus 8 lots of this. And here we go. Here's my next one. 3.26, etc. And finally, we'll do one more. Okay, and the final one, here it is, 3.273, etc. And again, I'm writing every single digit down. Okay. Just going to sort out one of the people on here who's been a little bit over silly. And that should be better. Okay, let's keep going. Question 16. I always get a little bit worried where there's a tiny bit of writing and then a huge page for you to do a load of work in. That says to me I'm going to have to do quite a lot of work, and there's only 4 marks. So that does worry me somewhat. Anyway, let's have a read through. The flight from London to Dubai takes 7 hours to the nearest 10 minutes. Okay, nearest 10 minutes says to me it's a bounds question, an upper and lower bounds question. The distance from London to Dubai is 3,400 miles to the nearest 100 miles. John says the average speed is definitely less than 500 miles per hour. Is John correct? Show your working. Okay, so I think the best way to do this, speed, distance, time triangle. We're working out an average speed, so I'm doing distance divided by speed. I'm working out average speed, so I'm doing distance divided by time. So I've got some combinations of things here. Let's see if we can do all 4 combinations. Now, I know lots of people, lots of teachers will talk about methods. My method for this is to do all 4 calculations, because again, I feel like in an exam it's very easy to make a mistake and do something a little bit silly. So what I think the best thing to do is to think about my upper and lower bounds for my time. So this is time, and do a similar thing for my distance. Distance, upper and lower. This has been 7 hours to the nearest 10 minutes. So nearest 10 minutes means if I half that, it would be 5 minutes, and I can add and take 5 minutes from this. So 7 hours, upper would be 7 hours and 0.5 minutes, and the lower bound would be 6 hours 55 minutes. There's another reason now when I'm thinking about this question being quite tricky. As soon as you start getting time, it's very easy, and I almost wrote it down myself as 7.05. It absolutely isn't. Remember, time is out of 60s as opposed to decimals being out of 100. Okay, let's do a similar thing with my distance. To the nearest 100 miles. So half my 100 gives me 50. My upper bound 3450. Lower bound 3350. Okay. I think the next thing I'm going to do is to turn my time into some decimal values, and again I can do that on my calculator. This button's really good for that. So 7 hours and 5 minutes equals, press my FD button, gives it me as a decimal. Okay, this 7.083 recurring is the same as 7 hours and 5 minutes, but as a decimal. So I'm just going to make a little note of those as well. Upper, I'm going to put as a decimal, just put a D next to it. 7.083 recurring. I'm going to do the same thing again, see if I can show you on the calculator. So I'm pressing 6, and then this button, it's this one with like a 0 and then a dash and then double dash. So 6 hours 55, press the button again, minutes equals 6 hours 55, no seconds to start with. Press your FD button or your SD button, depends what you've got, and again we've now got 6.916 recurring. So my lower is 6.916 recurring, again as a decimal. Okay, Artisan Rosie, if you're saying your calculator doesn't do time and you come to my school, then this calculator will be on your desk. So if you don't have that, don't worry. Okay, so now I'm going to do the calculations. The different calculations that we can do. We are doing distance divided by time. So I can do my biggest distance, 3450, divided by my biggest time, 7.083 recurring, as one option. Second option, I can do biggest distance divided by smallest time. Third option, I can do my smallest distance divided by my biggest time. And then my last option, I can do my smallest distance divided by my smallest time. I'm literally just going to type these in my calculator and work out which one. Well, it says, John says the average speed is definitely less than 500, so each of these should give me an answer that's less than 500. 3450 divided by 7. So the first one gives me 487 miles per hour. The next one, 3450 divided by 6. Gives me 498. Oh, 0.8 miles per hour. So that's close, but it's still under 500. Let's move the paper so you can see. Next one, 3350 divided by 7.083 gives me 472.9, and the very last one is 484.3. Okay, so highest possible speed is 499 miles per hour, which is less than 500. John said the average speed is definitely less. Is John correct? John is correct. It's really important once you've done a load of maths that you go back and just read the question. What were you being asked to do? This is what we were being asked to do, and I've made sure I answer it. Now I'm just going to go back to this point here. If when I leave the examination I can be 100% sure I've done everything that I possibly could do to be successful in the paper, then that's fine. I don't want to leave anything to chance, and this is one of the areas that it's very easy to leave to chance. Okay. Ooh, some more speed time. So this is a graph. Here's a speed time graph. We've got speed, we've got time. Work out an estimate for the acceleration. Now acceleration is the rate of change of speed, and the rate of change on a curved graph like this is the gradient. So we want to work out the gradient at this point when time is 4. Now this is a little bit tricky. I'm going to try and get a nice tangent to this and draw my line on, and I'm going to try and work out the gradient of this tangent, and then to do that I'm going to try and identify some nice coordinates as best I can. So I think I'm going to choose 2 and 29, and I'm going to go across until I find something else that looks nice. Maybe this point up here. So that point, let's just think about what I've got. So I've gone from 2 to 6, so I've gone along 4, and I've gone from 29 up to 42. 42 take 29, and I've gone up 13. Okay, so my gradient is 13 over 4, which I'm just going to write down here to start with, and I'm going to do 13 over 4 on my calculator, and that gives me 3.25. So an acceleration of 3.25. Now again, don't worry if when you come out of an exam and people are talking about it, say, oh, what value did you get for your acceleration? There's going to be a range of values, so just because you get something slightly different to somebody who you're talking to does not mean that you are incorrect. Okay, last one then. Use 5 strips of equal width to find the estimate for total distance travelled. Again, we can use the knowledge that on a speed distance time graph the displacement or the distance travelled is shown under the curve. So it's the area between the curve and the x-axis down here. Distance travelled in 10 seconds, 5 equal strips, 1, 2, 3, 4, 5, and basically what we're going to do is set this out in terms of either triangles or trapezium. Now when you do A-level maths, if you do A-level maths, there is a much more effective way of doing this, that means that you get it a lot more accurate, because at the moment, as soon as I draw this line here, you can see I'm actually cutting off some of the distance, which is why this is only an estimate. Okay, so again it says estimate, the process gives me the estimate, I don't need to do any further estimation. So I've got a triangle, I've got a trapezium, I've got another trapezium, and another trapezium. These ones up here are pretty good. You know that there's not much wastage. You probably can't see very well, but there's not much wastage at all at the top. Okay, the key things now is to work out the values as I touched my line across here. So at this point we went up to 26, so I've gone 2 along and 26 up. I'm just going to make a little note on my page of what my numbers are. So this is 26. At 4 seconds it looks like we're at 36. At 6 seconds 41. At 8 seconds we're at 44. And finally at 10 seconds it looks like we're at 45. Yeah, 45. And then I'm working out a triangle and these trapeziums, so the areas of them. area of a triangle, we do half base times height, so that's 1 times 26. So this one just gives me 26. I'm just filling it in here just to start with. My trapeziums, I find the average of the two lengths and times it by the distance between them. So this is going to be 31 times 2, which is 62. I'll use my calculator for some of the others because the number's getting a little bit tricky. Because 36 plus 41, divide it by 2. That just gives me the average between these two lengths. And times it by 2. So that's 77. Last ones, we've got 41 plus 44. Divide it by 2, times it by 2, 85. And these ones here, 44 and a half times 2 is 89. And I just need to add these numbers up. Okay, so 26 plus 62 plus 89, 339. So I get 339. I've lost my pen. Here we go. 339. Oh, I see. This is something else. Just be really careful. I didn't do this on purpose. I'm saying 339. I've got 339 written on my calculator, but for some reason I've written 336. There is absolutely no reason that I did that. I genuinely didn't do it on purpose. That's just a mistake. Okay. Let's move on. I've got about 10 minutes left. We've got quite a few questions, so I might just need to go a little bit quicker here, or just go over a little bit. Okay, next one. Diagram shows a cuboid. We've got area, ABCD has got an area here of 25 centimeters squared. The volume is 190 centimeters cubed. We want to work out the diagonal A to H, so it's going across the corners. What I don't know though, I mean that's a square, so that's 5 and 5, and that's okay. What I don't know is this length, and I need to know that length if I'm going to work out the diagonal. So I need to do 190 divided by 25, because that times the length will give me 190. So 190 divided by 25 gives me 7.6. So again I can put 7.6 on, and then it's basic 3D Pythagoras. So I'm going to do the square root of 7.6 squared plus 5 squared plus 5 squared. That's all I need to do. Type it in my calculator, and this is nice, quick, 3 marks. 7.6 squared plus 5 squared equals 10.38. Give your answer to 3 significant figures. 10.38, so that will be 10.4 centimeters. Okay, moving on. We've got the badge, which is formed of a sector of a circle and a triangle. Okay, we know OAB is 25, so I'm going to start writing some numbers in. OAB is 25. These are both radiuses, which means that this is an isosceles triangle, so that also has to be 25. 25 and 25 is 50. Take that from 180. This is 130. What we're trying to work out the area. So let's work out the area of my whole circle, and then I want to have just this proportion of it, which is 230 degrees out of 360. So I'm doing 230 out of 360 multiplied by pi r squared. Pi times my radius is OA is 3 squared. So this gives me the half circle, or the portion of a circle. I'll do that bit first. The sector, 230 over 360 times by pi times by 9 is, so this bit is 18.064. The next bit I need to do is my area of the triangle. I don't have a huge amount of information here, so I think I'm just going to have to use half AB sine C. So a half AB sine C. So that would be a half times 3 times 3 times sine 130. which is at 3.447. Add the two things together. And that's 21.51. Again, I'm just checking the question just to make sure that it doesn't ask for any kind of specific things, and it doesn't tell me how many decimal places, so that I think a little bit more accurate would be perfect. Right. Josh Groker, how can you be so good at maths? I'm new. Well, the more you do, the better you get. Same as everything. Okay, oh, these ones are good. This is another nice quick one. So we're fairly happy with the shapes of our graphs. I've got to just pick out some of these. First one, also I'm noticing there's no numbers, which is also really helpful. So first one, looking for a sine graph, H. Sine starts at 0, goes up and down. The fact that it's got 2 there is irrelevant. So this one is H. Next one, x squared plus y squared equals something, that's a circle. There is only one circle graph, that's E. Y equals 2 to the x. Best way to try and think of this is what happens when x is 0. You get y equals 2 to the 0, anything to the power of 0 is 1, so y equals 1. So when x is 0, y is 1. You can then choose some other numbers. Think what happens when x is 1 or 2 or 3. You'll see that you're getting bigger positive numbers for y. It's definitely A. And again, tan, this is tan, D. This is quite a nice, just knowledge-based one. The fact that there's some other numbers in there is irrelevant because there are no numbers on my grid. Okay, next one. 5 terms of a quadratic sequence. Okay, my daughter showed me how to do this in a really cool way, so all kudos to her really, and also Mr. Squires at Bolsover for showing her how to do it. Find your difference. So our first difference is 4, and then 7, and then 10, and then 13. Find your second difference, 3, 3, 3, and then there are a number of formulas that you need to know. You need to know A plus B plus C. You need to know 3a plus b, and you need to know 2a. And those are going to give you the different coefficients that go in front of your quadratic when it's in the form an squared plus bn plus c. Where do these numbers come from? Well, they come from here, here, and here. So a plus b plus c is 4. 3a plus b is 4, and 2a is 3. Now we just need to solve these equations, starting at the bottom, working your way up. A is 3 over 2. So straight away, I can start in my bottom line now to write that the quadratic sequence is 3 over 2n squared. Next one. If a is 3 over 2, and I've got 3 lots of this, I'm going to have to use my calculator here, so I've got 3 times 3 over 2, which is 9 over 2. 9 over 2 plus something is 4. So if I do 4 minus 3 over 2, minus 9 over 2, sorry, minus 9 over 2, it'll give me my value of b, which is minus a half. So minus a half n, and then my last bit I can just put in together. So I've got a is 3 over 2, minus a half, which is 1, therefore c has got to be 3. So I've got 3 over 2 minus a half plus c equals 4. C has to be, I'm just checking it, don't want to over confuse myself, but I just don't want to make a mistake either. Yeah, of course it's 1. So C has to be 3. So bottom line plus 3. Fab. Let's move on. Okay, next one we've got speed, frequency. Draw a histogram from the table. Okay, I'm noticing though that my histogram has got no labels on. this is really important, because up here I've got to work out my frequency density. Frequency, remember, goes inside the bar. So on this bit I've got a width of 15 and I've got a frequency of 6. So if it goes along 15, and so I'm trying to explain down here, if it went along 15, whatever 15 is, 15 times something will give me a rectangle whose area is 6. So I think the best way to do that is to do a division, and we're going to do 6 divided by 15, which is 0.4. So let me just write down class width is 15. Class width here, again, all I'm talking about when I talk about class width is just what do the numbers go from and to. 5, 5, 10 and 15, and then we're going to do frequency divided by class width to give me my frequency density. So I said the first one was 0.4, 10 divided by 5 is 2, 46 divided by 5, okay, is 9.2. This is going to really help me with my scale as well in a minute. 48 divided by 10 is 4.8, and 6 divided by 15, I've had once already, is 0.4. Okay, let's have a look. What's a histogram can I do with my calculator? Well, you can use your calculator to help. You can't actually do it on your calculator. A histogram's a bar chart. So all it is, it's a fancy name for a bar chart, but it's quite a specific sort of bar chart. Okay, let's keep looking along the bottom then. So what do my speeds go from? They go from 40 up to 90. If I started 40 here, can I go 50, 60, 70, 80, 90? Yes, I can. Lovely. It's always worth just counting out first. Make sure you're keeping equal spaces along the bottom. You're not trying to do anything clever. I've just worked out as a guess to see if I could go up in tens. Yes, I can. Right, on my scale here to here, my biggest frequency density is 9.2. So I'd like to think I can go from 0 up to 10. 1, 2, 3, 4, 5. So each one of these is going to be 2. So 2, 4, 6, 8. So I've got my frequency density and I've got my speed along the bottom. I'm labelling them up now before I start to draw them. Then let's have a look. So my table said between 40 and 55 I need to go up to 0.4. Now 0.4, 1 would be halfway between 0 and 2, so this is 1, and I've got 5 little boxes, so 0.2, 0.4. I'm going up 2 little boxes and I'm going from 40 along to 55. So start to draw it in. Now I'm doing it in pen only so that you guys can see. I don't think you'll be able to see otherwise. 55 up to 60, I want a frequency density of 2. So at this point I've done all the hard maths. I'm literally just copying down now all the information, taking my time, trying to do it as neatly as I can. 60 to 65, I'm going up to 9.2. So let's just work out where that's going to be first. There's 9 and one more box. And I'm going 60 to 65. Again, I'm just doing the top of mine first so I can make it neat. And down to the bottom. Okay, 65 to 75, I'm going to 4.8, which has 5, so this must be 4.8. 65 to 75, so this is slightly wider one. So this is the other thing that's different about a bar chart and a histogram. Histogram quite often doesn't have equal class widths, and therefore it's called a histogram. Okay, and the last bit. We're going from 75 to 90 across to 0.4. So 75 to 90, 0.4. Okay, now what we've done here, the areas here represent the frequencies. So this area is worth 6, this area is worth 10, this area is worth 46, this area is worth 48, and this area is worth 6. And again, you can double check that by using your numbers. We've gone along 5 up to 9.2. If you do 5 times 9.2, you're going to get 46. Okay, right, nearly there. I am just going to run over just a touch, but I think it's worth it. So, next ones we've got to do then. A, B, C are points on the circumference of a circle, the radius 4. So I'm going to mark on what I know so far. 4. This is again really good. I see I've done that and that was silly. That's not my radius of 4. This is because I'm rushing time pressure a little bit. Let's think what I do now. C to D is 10. That is something that I know. Okay. The radius of 4. Now I do know that a radius and a tangent meet at right angles. So from the centre, I can write this bit in as 4, and there's a right angle. I'm trying to work out the size of the angle CAB. So it's this angle up here that I'm trying to work out. There's nothing that jumps out at me that says that I can work that out. But what I can work out, I've got a right angle triangle. So I can work out either of these two. If I work this one out using normal SOHCAHTOA, I've got an opposite and adjacent. So I'm going to do tan, TOA. Why am I working this one out? Well, it's close to that one. That's my thought. So here we go. TOA. I've got tan to the -1 of opposite 10 over adjacent 4 equals tan to the -1. And again, just using my calculator at this point, so tan to the -1 of 10 divided by 4 gives me 68.2 degrees. So this angle is 68.2 degrees. And I'm going to label it on here as C, I'm going to call it O, COD, COD. The angle COD is 68.2 degrees. Now I'm looking at this thinking, what do I know? A circle theorem jumps into mind here. Angle at the circumference is half the angle at the centre. Now typically, let's see if I can try and explain here, this you would see what I call Star Trek. Normally it looks more like that, but if you can imagine that that point has been dragged around here until that forms a straight line, it's still one of your circle theorems. So that is half this. So CAD is going to be half of that, which is 34.1 degree. Okay, that might seem like a leap in the dark. These are proper grade 9 questions, so that's tricky. What I would suggest you do here is do some maths. I know that sounds really vague, but do some maths. Do what you can. Okay. Okay, again, I'm just reading through some of the comments, but it all looks like you're helping each other, so that's fantastic. Okay, last one then. Solve algebraically the simultaneous equations. We've got two quite nasty looking equations, but we do know that y equals something. I tend to put, when I see something like this, if it says y equals, I change the y in the second one to what it says it's worth in the first. Another massive clue, give your answer to decimal places, means I'm going to be using my quadratic formula at some point. So I'm substituting that into where it says y. X minus 2 lots of what was y equals 5. X minus, and I'm expanding my bracket out, so minus 4x squared plus 6x plus 14 equals 5. Collect all my terms together and make it equal 0 on this side so I can use my quadratic formula. So minus 4x squared plus 7x from here plus 9 equals 0. And then my quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. X equals. B is 7. So I've got minus 7 plus or minus the square root of 7 squared minus, plus, so I've got a minus and a minus, so plus 4 times 4 times 9. There's my C, there's my A, all over 2 lots of A, which is minus 8. At this point, I think I'm just going to type it into my calculator. I'm just going to do the add one first. So I'm going to do minus 7, add square root. In fact, I'm not going to do that. I'm going to press my fraction button first. You need your fraction button first, then minus 7 plus square root 49 plus 4 times 4 times 9, all divided by negative 8, gives me quite a horrible looking number, minus 0.86. So I wanted it to 2 decimal places. It seems reasonable that I've got minus 0.86. So there we go. Let's get my first one. X equals minus 0.86. Now that I've typed this in, I'm going to press my back arrow and just go back up to where I made it an add before and make that a minus now, so I don't have to type it all in again, and get my second value, 2.61. X equals 2.61. Once I know my X values, I can then substitute them in to the Y equals to get my Y value. So when X equals that, Y equals 2 lots of minus 0.86 squared minus 3 lots of minus 0.86 minus 7. And for the second one, again, I'm substituting my X value into one of my equations. I've picked the first one because I feel like it's going to be a little bit easier. 2 lots of 2.61 squared minus 3 lots of 2.61 minus 7. Again, type those in my calculator and get some Y values out. So the first one is going to give me minus 2.93, and the second one is going to give me minus 1.19. So finally, it says solve them simultaneously. X equals minus 0.86, and Y at that point is minus 2.93, and X equals 2.61, and Y is minus 1.19. Okay, so I've gone slightly over time. Hopefully that was helpful. This is a fairly challenging paper. All I can really do is wish you all the very best of luck for your exam on Thursday, and whatever doesn't come up on Thursday could come up the next Tuesday. This paper doesn't mean it's exactly going to be this. This is really just for you to be focusing on some of the things that we feel are definitely likely, possibly maybe going to turn up. Okay, best of luck, and I will see you all soon. Cheers, bye bye.